In this exercise, we will make a very simple thermostat part in ThermoFlo. Here we are assuming that our thermostat is operating between temperatures Tc and To. At any temperature below Tc, the thermostat is closed, meaning the radiator path should be closed while the bypass path is fully open. At temperatures greater than To, we want to have the radiator path fully open and the bypass path fully closed. Finally, at temperatures between Tc and To, the thermostat is opening, meaning there will be flow through both paths. If we choose, we can define any mathematical expression to dictate the behavior of each path in this range. But for this exercise, we assume that both paths are open in this range with elevated loss coefficients. Now let's define a non-dimensional thermostat temperature, T bar, as T minus Tc divided by To minus Tc, such that the thermostat opening occurs for T bar between 0 and 1. During this exercise, we'll see how to define a complex part with two flow paths, inlets and outlets. We'll create a form with user variables for thermostat control, define the behavior, and finally assign an icon to our part. In ThermoFlo home screen, first we click on Create Complex Part. We go to the desired folder and give the part a name and click Save. Now we go to the list of basic components and we choose a straight pipe to define the radiator path, and we copy this by keeping the control key down and dragging it down to define the bypass path. Now we make some adjustments to the parts. Okay, now we need to go to complex ports and get an inlet and two outlets. So we place a port for the inlet and we put two ports, one for the radiator to radiator outlet and one to the bypass outlet. Okay, now we want to connect the inlet. Since there are three nodes connecting, we need to get a connection node. So we go from the inlet port to the connection node, and from the connection node to the inlet of the parts. And we simply connect the end of the pipes to the outlets. Now to define the inlet and outlet completely, we double click on each and we give it a name and definition. This is completely optional. We call the inlet inlet, and since we know it's always going to be an inlet, we specify it as an inlet. Press apply. We do the same thing for the outlets. We give it an optional name, out rad, and again we specify this as always being an outlet. Do the same thing for the other outlet. Okay, now we display the part keys. We need to know that which path goes to the radiator, so part number 2 is used. Now let's define some user properties. We click on Add User Prop and give the first property the name TC, the label as it appears on the form. We call it fully closed. And we go to the unit type, and we know this is a temperature, so we click on temperature. degrees C is fine, and give it a default value of 82 for the fully closed. And now we go and again click on add user property, click on it to define, and give it a name TO for fully open. Similarly, we go to unit type, choose temperature, and leave the unit at Celsius and give it a default value of 92 degrees. Now we need to go define the layout and the form layout, and we just create a form from the user properties. Nothing fancy here. Now let's define our functions and tables. So we go to create table. The first one is our non-dimensional temperature, call it TND, and this is just a function. So define a function, we just use the independent variable of 1. That means nothing is going to change, and the value of it, we click on the calculator button and we can enter our function. So that's going to be T. Now we want to know the temperature of the inlet to the radiator. So that's why we wanted to remember that was part number 2. And we go to the location 0. So that's the inlet of the radiator minus TC. So that's a user property. We define TC. Now it appears there. So we click on it and select it. Now we want this whole thing to be divided, so we put a parentheses around it. And then we say divide by, and we go and say TO minus TC. Again, we choose everything from the user properties here, and you can see that the equation appears in the MathLook form, and it looks okay. So we apply that. So now we defined our non-dimensional temperature. So the next one, we create a table for K, loss coefficient, through the radiator. So call it K rad. And the independent property variable for this is going to be our non-dimensional temperature. So we go to our tables and pick TND, select, press apply to appear to that text box. Now this one is going to be at a step function. So we say from minimum to 0, so that's when it's closed, for all the closed conditions. And the radiator is going to be closed, so we give it a very high K value, like 100,000. Now between 0 and 1, that's when it's opening. Here you could define a function, or here we just choose a value of K of 5. And at the other end, from greater than 1, between 1 and 1,000 say, we give it a value of 2. So it's fully open with small restriction. So we press apply, and that table is created. Now we go create a similar table for loss coefficient through the bypass. So we call it K by. We keep the independent variable the same. All the ranges are the same, but the behavior is reverse. So in the min to 0 condition, we give it a K of 5, which means it's fully open, and we give it in the opening K of 10. Now at the other end, we want the bypass to be closed, so we give it a very high K. Press apply. Now if we look, we see we have all the different tables created in there in the modify. Now let's go and apply this behavior to our paths. So on the radiator side, if you wanted to, you could go ahead and give some typical values for the length and diameters. Here it doesn't really matter because everything is going to be determined by the loss coefficient. So we just give it some typical values. click on Advanced and turn on loss coefficient, and we take the value by pressing the calculator, and we go to our tables, and here we want the K to the radiator, and select. Don't forget to press apply, and you can see that expression is pasted to the loss coefficient for the radiator. So this part will always use that as the K through that pipe. And we do the same thing for the bypass side. Again, you can give it a name and some typical dimensions, which for this part really doesn't matter because these are very small K's as compared to what we already set in the part. So we go here and turn on the loss coefficient and enter the value from table K by for bypass. Press apply and apply here. So now our part is made. Now just to finish, we can go to general, and for the icon you can set any image. These images come from your part images and your folder. You can choose any image you want. Just happen to have something here that looks like a thermostat. We apply it, you can size it, and the easiest way is to do it and see what looks good on the screen. I think 40 was fine for this one. Now you can choose where to put your inlets and outlets. For this particular thing, I want to have the inlet to come from the right side, and the outlet to the radiator goes to the left side, and the bypass goes from the bottom of the thermostat. And that's again completely optional. So we define that, and we go and save our part. So we have a thermostat part now.